that's this here. And we have to figure out the width here. Okay. Now, one of the initial problems I see is that this is in feet and inches. They have to be in the same units. So we either have to convert the feet to inches or the inches to feet.
Inches to feet.
Inches to feet. Okay. So we do that by dividing this by 12. You got that calculator handy. Can you tell me what that becomes?
1.25.
Good. So the idea is that, and you can look at this two ways. It's like, how do you go from 30 to 1.25? Okay, meaning like what's the, I think of it as equation like 30 times K equals 1.25. And you can get what's called this scale factor. Okay. If you don't like that, we can set up a proportion. What do you think you would like to do here? What makes more sense, solving for this K or doing a proportion to solve for W?
The K.
Okay, so K here is the 1.25 divided by 30. Now, if you're going to go back to that calculator, which is good to do, I'm doing it as well. You're going to see that it gives you, in this case, a kind of a worst decimal, but you can hit that fraction button off to the right.
Sorry, I mute myself.
No problem. You can give me that fraction button or fraction answer for this.
Mm, 1/24.
Yes. Okay. So that K value is what you multiply the 30 by to get to 1.25. You similarly multiply 24 by 1/24 to get W. So in this case, W is 1 foot. Okay. So I'm gonna have to redraw here our what we've got here. So this is 1 foot. This was 1.25 feet. 1 foot, 1.25 feet. But if you go back and look at the question, it says, what is the perimeter in inches of the scale drawing? We got to convert it back to inches. So you already have the bottom. The bottom is 15. That didn't change. 1 foot, though, is the 12 inches. You're going to add them up for the perimeter. 12 plus 15 plus 12 plus 15. What do you get for that?
What was it? $54.
54 inches, perfect. All right, so let me go ahead and submit that. Hopefully there's no issues with that. All right, good job. Okay, so that's first question here. Let's look at the next one. So the types of problems you'll see here is they're either giving you the actual and the model, or the model and the actual in one direction or the other. Here we go. It says a scale drawing of a rectangular park had a scale of 1 centimeter to 60 meters. Okay. So in this case, they're telling you that like they're giving you on the left here the model or the scale. The actual one is much bigger, but we just draw it the same. And they're saying they're giving you the scale factor here. They're saying for every 1 centimeter, it's 60 meters. So to get this new length, you take the 9.6 and multiply by 60. And similarly, you take the 3.1 and multiply by 60. Okay, so can you do that for us, please? Give me those numbers here.
Okay. Sorry, I'm like writing it down.
Yeah, and if I'm ever going too fast, just say, not ready.
9.6. The first one on top is 576.
Good, and that's in meters. And then the one on the bottom, whenever you got it.
Oh, 186.
Good. All right, so the perimeter here, the shortcut for perimeter it's 2 times the base plus the height, or the length plus the width. If you want to do that shortcut, so it's 2 times 576 plus 186. The reason that formula works is because you've got 2 of the bases and 2 of the heights in the perimeter there.
Mhm. Oh, am I supposed to solve this last part?
Yeah, yeah.
Okay. Sorry, I was writing it down first. 1,506.
I got a different number here. I got 1524. Let me see, these numbers I agree with, 576 and 186. Yeah, I got this number here. Maybe you've got to put a digit in reverse or something.
Mhm. Oh, well, now I got a different one.
All right, let's
Oh, I got. Oh, yeah. Okay. I messed up. I switched the numbers.
okay. Great. All right, so actually this problem is really similar to the last, so this is good. We won't have to worry about a new case or something. So here's your new problem here. You got to identify whether they're giving you the scale drawing or the model. This is the scale / model. Wow, that's written poorly. Model. And then the actual, is over here.
Mhm.
So again, just like before, the reason you're multiplying is because of the unit conversion. It's 1 centimeter on the bottom becomes 110 meters on the top. The centimeters cancel. That's why you're multiplying. The 4.2 centimeters times 1 centimeters is 110 meters. And those do cancel. So from there, you do multiply these, and then we're looking for the area this time, not the perimeter. So we'll do something slightly different. So let's just get these numbers and see if we're consistent here.
Mhm. Sorry, we kind of went too fast.
All right. So yeah, so just trying to show you the
Oh,
calculations here, but really just doing the same things last time. You take 7.4 times the 110, the 4.2 times the
okay. Was I supposed to times the 4.4?
7.4 times 110, and then 4.2 times 110.
7. Yeah. 117.4.
No. Are you using that Desmos
Yeah.
scientific? Okay, so like the first one here.
You want me to do in the,
No, I wanted you to see how the calculations are entered. I mean, maybe there's just something else going on here. So, in the box, you just type in 7.4 times 110, 4.2
oh,
times
okay.
110.
It's
Yeah.
814.
Yes. And it's the reason I want you to use this is because you can type it the way you enter in the calculator the way you would write it out. It's more natural than trying to figure out parentheses and stuff.
Yeah. And then
Uh,
the next one is
and give me just
400.
give me just a moment. I'll be right back.
Okay.
Okay, so that gets you the base and the height of this thing.
Mhm.
814 and 462. So to find the area, it's base times height.
Mm. Oof,
You just read the
300
digits.
376,068.
Good, very good. Okay, is that conversion stuff clear? Because you said I went a little too fast and maybe I overcomplicated it. Or
Okay, so pretty much you kind of just divide these centimeters by 110 and then you times it.
well, I probably should have stuck with what I did in the last one, which is you just take the number and multiply by the conversion number. There is no
Okay.
division. There's no division. I was trying to show you why it works. Sometimes
Oh.
it maybe not necessary to know why it works.
Oh, okay. I get it. I get it. I get
Okay.
it.
Okay. Fantastic. All right. Okay. So we're
We can
all
move
done.
on to other.
Yeah.
Yeah.
So we're on to scale problems 2. Is that
Yeah.
scale word problems 2? Does that work for you?
Yeah. I want to see if it's different.
Yeah, it is quite a bit different.
Okay. Oh.
All right. So Isaac is planning to drive from city X to city Y. The scale drawing below shows the distance between two cities with a scale of 1 inch equals 16 miles. And then there's a little bit more here. So the first thing we want to figure out is the distance in miles. So you take these two numbers and multiply them together.
Okay. Mm. 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 It is or 72. I thought it was negative.
Okay. So 72, I agree. That's the miles, okay? And they're saying they can drive 30 miles per hour. That's where you are dividing. You're taking 72 and dividing it by 30.
2.4.
Okay, so we got to be careful here. It's 2 hours because of the 2.4. The 0.4 is in terms of hours. So to get it to minutes, you multiply that by 60.
Mm, 1 multiplied by 6. It is 240.
0.4 times
Oh, 2.4.
just the decimal part, the 0.4.
Sorry.
Time is one of these really awkward things. We live in hours and minutes, but computers do it in decimals like this, and it's like we never have to do this ourselves.
0.4 times. Yeah, 24.
Yes. So let's look at this, just, kind of go through it one more time again. They give you the scale drawing, you convert that to the distance, and that's like what we did in the last problems. But now they're giving you some sort of rate of travel, so you can figure out how long it took to go this distance, and the answer's in hours, so you have to convert the decimal part to the minutes.
Oh, okay.
And like Google,
Okay.
if you're using Google Maps or your Apple Maps, whatever it is, or whatever it is, I use the Google but Maps, but that's how they do it. They do exactly what we just did in some ways. All right, so if you enjoyed that problem, looks like we got one just like it coming up here. Okay. All right, so this one is a slightly different conversion. So it's 4 inches, but this time it's a ½ inch to 17 miles. So you're like, well, how do I handle this? Well, you can always manipulate your conversion. Like if you multiply your conversion by 2 to get to 1 inch, and multiply this by 2 to get to 34 miles. Now you've got the conversion that you want.
Oh.
So now you're gonna take your 4 inches and multiply it by 34. Okay, so we're gonna get that distance. We're gonna calculate that for us.
Um. 136.
Okay, so now you take that distance. No, that's not right. That's not that 4 times. Oh, that is right. I'm sorry. That was like, that didn't jive, but it does work. 136, and you're going to divide by the rate down here.
Okay. It is 3.4, and then
So that's the 3 hours. And then you take the 0.4 and multiply it by the 60 minutes, which will again be 24 more minutes. Is that okay? Make sense?
yeah. Yeah.
All right. Should we do one more to close it out? 3 for 3?
Yeah.
Okay. All right. Notice I'm not even reading the problem because they are the same. This one is 3 inches, ½ inch is 15 miles. So you go to 1 inch by multiplying by 2, 30 miles by multiplying by 2. So you're going to take that 3 and multiply by 30. Which is
90.
90, and then you're going to divide it by 50.
1.8.
1.8. So that's 1 hour, and now it's 0.8 times 60.
$48.
48 minutes, good. So believe it or not, like before phones and GPS things in the car, like people would actually look at maps and kind of do this type of, figure out how long it's going to take to get places. And
Yeah.
we don't do that now. We'd never think to do that now. All right. So that takes care of both scale word problems. I guess there's percent change word problems. There are quadratic word problems. Any Pythagorean
Any
theorem
word
word problem?
problem.
Okay.
I can do the Pythagorean theorem word problems.
Okay.
I want to do that.
Let's do the percent change word problems
Okay.
next. These aren't that difficult, but well, those are famous last words. I don't know. I was thinking they wouldn't be that bad, but looking at one, I'm like, oh, okay. All right. Investor has an account with stock from two different companies. Last year, stock in company A was worth $12.50 and her stock in company B was worth $4.50. The stock in company A has decreased 10% since last year, and the stock in company B has decreased 4%. What was the total percentage decrease in the investor's stock account? Okay. Yeah. So here is for company A, it was $12.50. Okay. And it went down 10%. So rather than figuring out like what it went down by, you multiply by 0.9 to get the new value. Do you see that? Like if you multiply by 0.1, you get the decrease, but we don't care about the decrease. We care about what was remaining. You don't like that. Okay, let's do it the way let's do it that way. Let's multiply by 0.1. So the decrease is 125. Okay. And company B, its decrease is, it was 4,050, 0.04. You want to calculate that for us, please?
$162.
162. Okay. So the total here is 287. 287. Okay. That's the total amount of like money that it went down. Okay. But we don't care about that. We want the percentage. So the percentage that it decreased is 287 out of the 1250 plus the 4050. Right. And this is where that Desmos scientific is really nice, because you can enter it without these parentheses. You just have to get that fraction bar and get both of those numbers on the bottom there. So when you enter it, you might want to hit that division first, and it'll give you a numerator and a denominator to make it a little bit easier to enter. It is a decimal. What do you see?
Oh, well, it gave me 5.6691.
Nope.
358.
So you got to have this whole thing has to be on the bottom.
Yeah, I did that. Oh, okay. I think I know where I messed up. Okay. Oh. Okay, I have to do this again. Sorry. Oh, it's plus, right?
Yes, yes.
1, 2, 8, 7, 12, 15, 20. It gave me 0.0541.
Yes, and that is correct. So that, but
Okay.
again, they want a percentage. So we're almost there. You got to multiply the whole thing by 100. So you can put some fraction bars around it like that. To do that, you can highlight the whole thing and add in a parentheses. Like if you literally highlight over it and put a parenthesis, it'll put it around it, and then multiply by 100. That could make it easier for you. You'll see though that it's 5.4 rounded to the nearest tenth if you do that.
Parentheses. 5.4. And okay, yeah, 5.4.
Okay, awesome.
Okay.
All right. So let me, sorry, I got too many windows open. There it is. So that was a lot harder than I thought these were going to be. But that was correct. So the nice thing I think here is that the next ones are going to be very similar, which is we're going to calculate the two decrease amounts. We're going to add them up and then divide by the total. Yeah. All right, so investors account again. So A is 6,600. B is 3,500. Okay, this time though it increased. So when it increased, this is kind of the awkwardness of it, is you really want the new amount. But let's just do it the way we're doing. So let's do the 0.07 again and the 0.01 again. You want to calculate that calculate those for us, please.
Mhm. The first one is 462.
Okay.
And the second one is 35.
Okay, very good. So we're going to add those together. That's 497. Now, last time we divided it by the total. The problem is when it's an increase, like this 497 is an amount on top of what you started with. Like it went up by that amount. Okay, so
Mhm.
typically, and I guess we'll just try it and see if this works. You would do something different, but let's just try this again and see if it works. Don't forget to multiply by 100 here. I don't want to overcomplicate this for you because I think probably this will work.
is 4.9.
4.9. Yeah, that's what I got as well. Okay. Hopefully it will take that. Submit answer. All right. That is good. So next problem here looks like no more money problems, but kind of the same scenario. All right, so there you're going to take the given values here. So there's 50 boys, 120 girls, 22%, 15%, basically the same thing as the last two problems there. Do you feel comfortable trying this on your own, or do you want me to lay out some of the numbers for you on this one?
The percent, do I just put like a point in front of it and I
Good,
like
good
one
question.
five?
Good question. You're supposed to divide by 100. So in this case, because they're two-digit numbers, it is just 0.15 and 0.22.
Mm-hmm.
But in the last one where it was 4% or 1%, what you're actually doing is you're moving the decimal over 2 times, and that's where that zero comes in for that.
Okay.
But this one, just to be short and compact, it is 0.22 and 0.15.
Um, mhm. The first one is 11 and the second one is 18.
Okay, that's good. So you're going to take those two numbers, 11, 18, and divide by the original totals.
Mm. It is, oh, okay, I messed up part of it. 0.17.
Yeah, so but that's you're gonna have to multiply by 100. Don't forget to because it's a
Oh yeah.
decimal, and you got to multiply by that. And so this one, when you get the number there, you're going to see 17.058.
Okay.
Well, since you're rounding the nearest tenth, is it 17.0 or 17.1?
17.1.
Yes. Good. All right.
Okay, that wasn't that bad.
Yeah.
But
right.
this time, why did we add the top? Oh,
Because I didn't add them
oh,
up
okay.
here. Yeah. Good. Like I like that you noticed that, because you're not just saying, oh, put the number here and there. You're trying to think through the problem and figure out why the numbers are going where they're going. So I think
Mhm.
that's great.
That's why I don't like the examples that they give on Delta Math, because there's hardly any instructions to it.
Yeah. They're hoping you'll just figure it out, I guess. I don't know.
Yeah.
All right. Quadratic word problems is the next one I see. Is that okay, or do you want us to pick something else to look at?
That's fine.
Okay. All right. So a rocket is launched from a tower. The height of the rocket, y in feet, is related to the time after launch, x in seconds, by the equation. Find out the time which the rocket will reach its max height. So here are the typical scenarios for a quadratic. You're either finding the vertex, which I'll call like point 1 or region 1, and it could be asking for the x or the y value there, depending on the problem. And then
Mhm.
the other possibilities, they're asking about 2, which is where it hits the ground. or the water or whatever it is, okay? In this
Mhm.
problem here, we're asking where it will, we're finding out the time at which the rocket will reach its max. That's up here at 1. You have to decide whether it's asking for the X value or the Y value. Time is the input, so they are asking for the X value in this problem. Okay, so I'm trying to say is that they could be asking for, vertex X, vertex Y, or the X value down here. All right, now how to actually do that. To find the vertex of a quadratic equation, there's a couple ways to do it. One is to use formulas, and X max equals minus B over 2A. If you don't like that, or if you're allowed to graph, are you allowed to go to like Desmos and graph this?
Mm,
Like, or will this appear like, when you had to do it for real, will you have access to a grapher?
probably.
So I can show you that, or let me try to decide here. I'm trying to decide what the best thing to do to help you with this is.
I feel like I do better with formulas.
Okay, let's stick with the formulas then. So A in this problem is minus 16, B is 193, C is 128. Those are the numbers in front of x squared x and the constant. They include the operator. So if like this plus in front of the 193 is a minus, it would be minus 193. So you're just substituting those numbers into here. X equals minus 193 over 2 times negative 16.
Mm, 6.0
So this time they want you to go to the
or
nearest 100th of a second. So you got to go out 2 decimal places. So 6.031, which rounds to 6.03.
okay.
Is that okay?
Yeah.
All right. Now, if we were asked to, we're not asked to in this problem, but if we were asked to find the max height, you would have to take this number and put it back into the original. And
Um,
maybe we'll see that in another problem. We don't have to do that here, but we'll see. All right, new question does appear to be very similar. All right, company sells widgets, profit at Y is related to the selling price X. Use the equation, find out what price the widget should be sold for to the nearest cent for the company to maximize profit. So this time price is here, profit is here. And again, it's got some sort of shape where it comes up and reaches a max. And we're again interested in the vertex this time.
mhm.
Because it wants the price of the widgets, that's looking for the X value of the vertex. Okay, so this is AX squared plus BX plus C. A is minus 30. B is 1,325. We actually don't need C for the vertex. So go ahead and calculate this for us, please, and let me know what you come up with.
Um, Mm. Um, um, is it negative 22.08?
It is, it's 22.08. So you must have
Oh,
either not put in a negative or I don't know, I maybe add an extra one, but it's got to be
oh, you
positive,
know.
but just double check
Yeah.
that. That looks correct. Let's see if we can
The
get this.
2A, the A also becomes a negative. Oh, wait, I didn't see the
Yeah.
negative in the
Yep.
problem.
Yep.
Okay.
Yep. Good. All right. All right. Last one here. Let's see what it wants. Okay, so this one you've got to find both the X and the Y value of the vertex. Let me snip this in. All right. So the X value of the vertex, just because we're short on time here, is minus B over 2A, which is minus 275 over 2 times minus 16. And go to your calculator and see what you come up with on that. And this time you want to go out a few more decimal places. Like I'm going to go out 4 decimal places.
Okay.
All right. So now
Mm,
in terms of how you get the last part of it here, you take that value and you put it in for X. Okay. Now in Desmos, there's actually a better way to do this than, and I'm going to just show you here. I'm going to type in X equals 8.5938. And then I'm going to write Y equals minus 16X squared plus 275X plus 127. And the calculator knows to put that value in for X. And I'll show you that here next.
oh,
So let me show you that here, snip that in with the full answers here. I don't want to be cruel and stop in the middle of a problem. That doesn't help you very much. So see, I typed in exactly the way it's written and it gives me the answer here. So the nearest tenth, it's 1308.6. All right, is that okay?
I didn't really understand the last
Okay.
part.
All right. Well, yeah, it's we can muddle through that another time here. But
Okay.
that will do it for us for today.